Now, the conclusion of this, again, why do we care about concavity? The second derivative test. It's just another test to find extrema. This is also where the names of the tests become important and confusing, so pay attention. So, the second derivative test says if we have some function f, so that's a function, such that the derivative of f, the first derivative of f, at some value c equals 0. So what is that telling us? It's telling us that c is a critical value, what we were calling critical values before, right? That's just a critical value. And the second derivative of f exists on an open interval containing c. That's where the test part's going to come in. So then if the second derivative of c is greater than 0, then f has to have a relative minimum at c comma f of c. And if the second derivative of c is less than 0, then f has to have a relative maximum at c f of c. If the second derivative of c equals 0, then the test fails. So that just tells us that we need to try something else. So f may have a relative maximum at c, or it may have a relative minimum at c, or it may have neither. So if the test fails, then we have to do the first derivative test. That's what this is telling us. So this, again, it should make sense. Think about, what does the second derivative tell us? Second derivative tells us concavity. So if I know that I have a critical value from the first derivative, that means that that point is a possible relative minimum or maximum. Remember that critical values are the only places where relative minimums or maximums could occur. So if the second derivative is positive at that location, that means that the function is concave up. So if I have a point that could be a relative minimum or maximum, and then I find out it's concave up there, then it has to be a relative minimum. If I find out it's concave down, then it has to be a relative maximum. So here graphically we can see what that would look like. That I know at these points, at the critical values from the first derivative, those are the only locations where I could have a minimum or maximum, because I'm getting them by finding the derivative when it equals 0, which means that there is a horizontal tangent line. So we know that it's either a relative minimum or maximum, or it's not, but if it's concave up, it has to be a minimum. If it's concave down, it has to be a maximum. All right, that was a lot of rambling. So let's just get to it. All right, so we're going to go through this example together, and then you will do one on your own. First derivative. So the derivative prime x equals negative 15x to the fourth plus 15x squared. Okay, now let's find some critical numbers. So we're going to say 0 equals, we're going to factor out negative 15x squared, and then we're left with x squared minus 1. Set each of these equal to 0. So negative 15x squared equals 0. X minus 1 equals 0. X plus 1 equals 0. I just factored that, that's all. Don't freak out, right? Don't freak out. So I get x equals 0, x equals 1, x equals negative 1. So these are critical values from the first derivative. So now we're going to do or find the second derivative. So back up here. So that is just going to be f double prime of x equals negative 60. Whoops. 6d, I said it, I just wrote it wrong. 60x cubed plus 30x. So that's my second derivative right there. Okay, now we're going to do the second derivative test. I had to make myself a little more room. So second derivative test, all that says is just plug these values into the second derivative. So f double prime of 0 is 0, failed test. F double prime of 1 is negative 30. and f double prime of -1 is positive 30. Okay, so these are successful. So what this tells me right here, now this is not, I gotta answer this in derivative speak, but I know that at the value x equals 1, the function is concave down, so therefore I have a relative maximum. At the value of x equals -1, function is concave up, so therefore I have a relative minimum. Okay, so since this one failed though, I do need to try and do an increasing decreasing chart to see if it is actually a relative min max or not. So again, f prime. Now, I know that 1 and -1 are already relative minimums and maximums, so I still need to put these on the chart though, just so when I'm testing 0, I don't pick anything outside of 1 or -1. So I need to pick something between -1 and 0 and something between 0 and 1. So let's do -1/2, and let's do 1/2. And then remember now we're plugging these into the first derivative. And I can see that actually it's not going to matter because I'm raising this to the fourth and this squared. So I know that these are going to come out to be exactly the same. I just need to figure out if it's going to be positive or negative. And I know that because this is to the fourth power, that's going to make the number smaller. So times 15 would make this smaller. So this is going to come out to be positive. So I know that this is going to be positive and this is going to be positive. So therefore, 0 is not a relative minimum or a maximum. Okay. Now let's answer our problem using our derivative speak, but our derivative speak is going to change slightly here because we used the second derivative test. Also, let's actually find out what these points are real quick though. So if I do, whoops, f of -1 is going to be, let's see if I plug that in, -2. And f of 1 is going to be positive 2. Okay, so now I know the points. So let's do our derivative. So I'm going to say, since f prime of 1 equals 0, and f double prime of 1 is less than 0, sorry, I just had to check that, then I know at 1, 2 is a relative max. So again, this tells me it's a critical value, this tells me it's concave down, therefore it has to be a max. So then we can also say, since f prime of -1 equals 0, and f double prime of -1 is greater than 0, at -1, -2 is a relative min. There we go. All right, I want you to try the next one. So find the first derivative, the critical numbers, second derivative, try the second derivative test, talk about relative minimums and maximums, and I also, just for the fun of it, want you to find any inflection points. Go ahead and do that. Pause the video, unpause when you're ready to check. Here we have a lot of information. So let's just start from the top. F prime of x is 4x cubed minus 12x squared. Set that equal to 0. Factor out 4x squared. Find our critical values, x equals 0 and x equals 3. Those are my critical numbers. Find the second derivative. F double prime of x is 12x squared minus 24x. Great. Try our second derivative test. F double prime of 0 equals 0. Failed test, not failed life, though. Just that test. F double prime of 3 equals 36. That is good. That tells me, since this is positive, at 3 has to be a relative minimum. Now over here, I want to try my increasing decreasing chart just to really see, is 0 a relative minimum or maximum. I plugged in -1 and +1. I have to be careful not to plug in anything larger than 3. And I see that they're both negative. Remember, I'm plugging them into the first derivative. So that just tells me that 0, although it was a critical value, is not a relative minimum max. Now I can answer the minimum or maximum problem using my derivative speak. So since since f prime of 3 equals 0 and f double prime of 3 is greater than 0, at 3 comma negative 27 is a relative minimum. Moving on, let's find points of inflection. So find my possible points of inflection. I have my second derivative, set it equal to 0, factor out of 12x. I end up with x equals 0 and x equals 2 as my possible points of inflection. So now I'm going to do my concavity chart. So this is f double prime, remember? So I have my possible points of inflection. I plugged in -1, 1, and 3, and I saw that this was positive, this was negative, and this was positive. Therefore, I'm going to have 2 points of inflection. So I can say, since f double prime of x is greater than 0 on negative infinity to 0, and f double prime of x is less than 0 on 0 to 2, at 0, 0 is a point of inflection. And since f double prime of x is less than 0 on 0 to 2, and f double prime of x is greater than 0 on 2 to infinity, at 2 comma negative 16 is a point of inflection. Okay, so now I want to emphasize we have three kind of things that we have learned to test at this point. We have our first derivative test, which uses critical values from the first derivative and an increasing and decreasing chart from the first derivative to determine where we have relative minimums and maximums. We have our concavity chart, which tests for inflection points, finding possible points of inflection from the second derivative and then testing them on the concavity chart. Then we have the second derivative test, which also allows us to find relative minimums and maximums like the first derivative test. Here we take our critical values from the first derivative and we just directly put them into the second derivative to see if they are positive or negative to determine our concavity, which will then tell us if something is a relative minimum or maximum.